A teaspoon of pepper. Okay.
All right.
So
Oh,
here we go.
no? Is it gonna go?
I don't know how to make snails.
Come on.
But after you put the butter on, I'm gonna guess.
Work with me here.
So now we're gonna take Charlie. So
I need it.
Instead of saying a teaspoon of pepper,
I need it to work.
we're gonna take Charlie.
No, we're not going to be streaming Overwatch.
Nothing is better than
Charlie's
Overwatch.
holding a teaspoon of pepper. Now let's say someone else takes the recipe.
Oh, hey, it says it's starting.
Let's say there are.
It says it's receiving content.
Let's say a teaspoon of
Hey, we're live.
is used for every single snail.
But it's still, why is this still? Oh,
Rewrite a teaspoon of snail
okay.
over and over and over.
There we go. So I set up this blog, right? And whenever we're done streaming, YouTube's going to process the video and it's going to show up on this blog. If I need you guys to be able to get to a link that maybe I've made a cheat sheet or I found a website for you guys to use, it'll be on here, just so it's easy and you guys don't have to like type in address in your web browser for something you need for class, because the keywords on these are really small that we're going to have. Queso's on the way with them right now. But for the time being, what we're going to do is we're going to look at Raspberry Pis and what they look like.
Oh, that's what it looks like.
Yes.
And my dad is working on one of those. He's making one of those computers that like they make you money. He has like there's like this certain computer. It's like with the motherboard. He just like he's making it like to make money or something. Like he's
the Bitcoin miner.
Huh?
Bitcoin miner.
I think. Yeah, he's making.
That's not what we're talking about today. Okay. So what you have here, that's an Ethernet port. That's how you connect to the internet, essentially, or networking. You got USB ports, I'm sure you've seen those before.
Yep, I've seen it.
That's an aux port, that's our HDMI cable.
Yeah.
These are called GPIO pins, which is general purpose IO pins. And that's for like digital circuits. So if you guys wanted to add like a motor to this or something odd like that, you could. We're going to be using those to connect our Raspberry Pis to what we're calling the PiTop Hub. And the PiTop Hub will connect the Raspberry Pi through our HDMI cable to the speaker. It will connect it to the monitor. It will connect it to the battery. And it will connect it to a power button. And I think that's it. So let's see here. The HDMI cable right here is it's like really small. It's going to connect from this to an HDMI port inside the PiTop Hub. The PiTop Hub is going to have a USB port that delivers power right here for our Raspberry Pi. And then we're going to use one of these USB plugs to connect our keyboard and trackpad. And then our PiTop Hub. Let's see if I can find a picture of that. Can I not search? PiTop Hub. Can you see that?
Let's go with Roman. What's going to happen when this line runs? Good.
Yeah.
Now,
here we go. That's what we're looking for. Okay. So HDMI cable connects here, and then this is USB cable, and it plugs in right here, and that gives power to the Raspberry Pi. Now what this does is it connects right here, and that gives control. Basically, this sends a power on signal from our power button that's on top of our keyboard, right over here. And let's see here. And it connects and it controls like the brightness and such on the monitor. And what else does it do? Oh, it said no. HDMI sends audio. And it gets battery information for how much our battery is charged. And this big gray thing, that is our battery. It gives us temperature information, I believe. Oh, and one other thing. There's a little silver block that we'll get as well, and it goes right here. if we look at this chip right there, that is our CPU. This is our RAM. Oh, and there's also an SD card that goes right here, and that's where it stores all of our files. But this has our Wi-Fi chip in it, it has our processor in it, it has our graphics processor in it, and these things are like $35 if you want to buy one, just this part alone. And they're really cool. You can do a lot of stuff with them because they're surprisingly powerful. And you can add all sorts of stuff onto it with this. So it's really neat. Oh, something else. This part right here, that is a very, very thin cable that connects the screen to our Python hub. Whenever we attach that, you need to be very, very, very careful. Okay? So that's just something to keep in mind. How many of you guys have used Windows before? Yeah. We will not be using Windows. We are going to be using Linux. And we'll be learning Python this week after we build our laptops. And that's how we'll learn programming. So, something you'll need to be familiar with is your terminal. And I'm going to log in to a supercomputer that I still have access to for my university, just because it's Linux. So I can show you guys how that works. Trestles will work. So what a supercomputer is it's basically a whole bunch of computers that are connected to each other on the same network. And they basically work together to do really complicated things. But anyways, so your computers have files and folders, right? Does that make sense to everyone? Folders are inside folders, inside folders, inside folders, and files are inside folders. Pretty simple stuff. Your command line, your terminal, is what we call it. It operates in what we call a working directory. And that's where you see what files are inside a certain folder. So right now, I'm inside what we call a home folder. And to find out what is inside the folder you're in, you type ls. There's nothing in my folder right now. ls-a. Okay. So, whenever you type ls, you're going to get a list of files, kind of like this. So I have a file called .bashrc, I have a file called .bashprofile, .bashhistory. Now there's two special folders. One is dot, and that just refers to the folder you're currently in. There's another one called dot dot. That's the folder you're currently in is inside of. So if you're in folder BBB, which is inside folder AAA, dot dot refers to AAA. Does that make sense? Raise your hand if it does not make sense. Okay, never mind. Okay. So my terminal is inside my fingers. It's inside my thumb. That's where my terminal is. My thumb is inside my wrist. It's inside my hand, right? So dot is my thumb. Dot dot is my wrist. Does that make sense? Okay. So whenever I'm inside my thumb and I type ls, I get all the parts that are inside my thumb. So they get dot, I get dot dot, and then I get all the files I have in there. So if I have pictures, if I have a program in there, if I have a Word document or something like that, ls will tell you what else is in there. Now, there are, of course, different kinds of files, like picture files, Word files, PowerPoints, movies, that sort of thing, right? There's also a program file that you can make code and you can run your program. We're going to be using a program called Python 3. So if you just run Python 3, the supercomputers don't have Python 3. We are going to be using Python 3. If you just type Python 3, it pulls up this code right here, or this screen. Okay.
And that's like a recipe. It's like a step that need to occur.
This stuff is highlighted.
That recipe is called a function.
Everybody see that? And you can just type in Python code. And once you type in a line, you push enter and it runs that line. So I can say x equals 5. And it just assigned 5 to a variable called x. Make sense? Easy peasy lemon squeezy. Okay. Now, what do you think is going to show up if I type 5 times x? 25? Anybody have any other guesses? 25? Yeah?
And it goes, okay,
What do you think?
run through all those steps. When I'm done,
Enter.
come back here.
Whoa! Is that
Go
25?
print again. Whoops, go back to the print. Run all those
Nifty
steps.
stuff, right?
Come back, I'm done now.
Okay. Now, 5
So this,
without a decimal point is something we call an integer.
and it's gonna be
Okay.
an indicator on your
So, are any of you in algebra?
console. And also, it'll wait for you.
Are any of you in algebra?
Yeah.
Pre-algebra?
I'm in algebra.
Press enter.
Kinda?
No.
Kinda in algebra?
When you come, it replaces it.
I'm
How are you
in.
kinda in algebra?
Sometimes I do, sometimes
Okay, okay.
Well, not currently.
Not currently. Last year.
I'm in algebra.
Nah. But you understand how variables work, right? At least that much. Okay.
I'm in.
Good.
So, right, there's different kinds of numbers. You have natural numbers that you can count on your fingers with. You have
Then it's going to get stuffed inside of
whole numbers. I can't remember the actual name of them, but they don't have decimals. Oh, they're called integers. Integers do not have decimal points. Right? That's the main thing about them. Then you have what we call real and rational numbers. Those can have decimal points in them. There's also imaginary numbers, but we're not going to do that.
What are those?
Yes.
So, you guys ever heard of like?
Can anybody tell me what the square root of 25 is?
5.
5. What about 16?
4. No, 4.
4. Good. What about negative 1?
Okay, how would I? I want the computer to do something.
No. What's negative 1 times negative 1?
Negative 2. Wait, negative.
What?
Is it? Negative 1 times negative 1 is 1.
Isn't that like what property is that?
It's just 1. Right?
Yeah, I said it.
But if negative 1 times negative 1 is 1, then what's the square root of negative 1?
You like enter a noun.
2.
Nope.
1.
Square root of 2 is something like 1.4.
You want to combine?
No! What's negative 1 times negative 1?
You can do like
Negative,
It's just 1.
negative 0.5.
Nope. Negative, or 0.5 times 0.5 is 0.25. So, the square root of negative 1 is what we call I, which is, if you have something multiplied by I, you call that an imaginary number. Not super important because, like I said, we're not going to be doing that in programming, but the more you know. Fun stuff. Okay? So, if we say the type of x, it's going to say int, which is short for integer. Everybody see that? Normally, once I figure out the sound, we'll be able to watch it on the TV, and you guys will actually be able to hear this a little bit better and see what I'm showing on the screen, because it'll be bigger. But, let's see. What else? But if I say the type of 5.4, we get floats.
Float?
You're going to be doing this, but make it like way cooler and way more interesting.
See how everybody? Cool stuff? Alright. Now, you guys don't always want to use numbers for variables, right? There's other stuff you want to use. Okay? Like true and false. Those are called booleans. Those are the only two values a boolean variable can have. True and false. Now in most programming languages, those are lowercase, but in Python they're capitalized, so it's capital T R-U-E. Does that make sense? Okay. So if I type x is greater than 20, am I going to get true or false? False? Why do you say false? 5 is not greater than 20, right? False. Look at there.
Hang tight. Okay.
You see it there? Okay. Now, just show of hands, how many of you remember everything we've gone over so far?
What?
Raise your hand if you've forgotten something. I just want to say right now, if you guys have questions or if you want me to go over something again, please ask me, because I really want to make sure we're all on the same page. It'll just help the week go a lot smoother. So, Damon, you said you forgot something.
What does the arrows mean? After it's the last thing you do, the last thing when it said false. What does that arrow mean?
So, what the 3 arrows you're talking about? That's just what we call a prompt. And so it's saying, okay, you can type something now. Does that make sense? That's all it is. Any other questions? No? I'm sorry, normally I would have you guys have your PyTops out and be doing this with me, but we just don't have them right now. And also we'd still have to build them. Yeah, Queso is on his way back. He has to walk all the way back to the lab, because what happened is we had a camper who was late, and so he had to walk from here because he can't drive them, and then he has to walk back, and then he's going to put him in his car, then he's going to drive him here. He's going to walk up the well. Yeah, because he won't have a camper with him, so he can drive them.
So how are we going to do it? Probably after lunch or something?
Yeah.
No, we'll start them way before. We should finish them today. Yeah. 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 No, the rest of the week we're going to be programming. Building the laptops is just kind of a day one thing. And if you don't finish them today, I'll probably finish them after you guys go home.
So do we get to bring them home?
Yes, at the end of the week you get to take them home. But until the end of the week they stay here.
Oh, right.
Yeah.
Oh, really? Cool.
Oh, they're all programmed by today.
Cool. So there's booleans, and you can assign a value to booleans. So now, y equals x is greater than 20. Okay. Everybody good so far? Alright. Yeah. Now, I'm going to go back in and I'm going to say x equals 340. What do you think the value of y is?
That's the power of the sun.
So are you making like a new? So are you?
Hang on, one at a time. What do you think?
So wait. So if y is
Do you need to look at it closer?
well, would this mean that y is 5 greater than 20? Is that what that means?
That's what it meant when it ran. What do you think the value of y is now?
340 greater than 20, so 360.
Is everybody here set? Okay, that's good thinking, but you were right the first time. So, whenever we said y equals x is greater than 20, x at the time was 5, right? Okay. So, is 5 greater than 20? No. So it gets false. So now y equals false. But if I change the value of x later, it doesn't matter. Y is still false. Okay? Is that good? Yeah? Are you good, Lewis? Yes? Okay. Is everybody still on the same page with me? Have I forgotten anything? We're all good? Sweet. Okay. Okay. Now, how many of you have done any programming before? I know you have. Seth, you've done some? You've done some? Done some? You've done something? No? Okay. So, that's okay. That's cool. So, there's something in programming called control flow. Okay? So, a control flow is controlling how your program flows. As in, what you do next. Yeah. So, most of the time, for more than likely, nobody will do anything differently. Maybe, but probably not. Computers do one thing at a time. Your programs do one thing at a time. So, if you say x equals 5, y equals 5 times 20, it's going to say x equals 5, and then it's going to say y equals 20. It doesn't happen at the same time. Control flow will say whether or not you do something, and if you do something, how many times you do it. So one of the most basic control flow concepts is an if statement. And so what an if statement is you type the word if space. What's that?
Oh, if you want to fit back in your chair. Oh,
well, some people have not though. So with Python, you type and then space. Now, those of you who have programmed before, you usually have like parentheses. In Python, you don't need the parentheses. So you type if space, and then something that is a true or false value. So it can be greater than, it can be less than, it can be greater than or equal to, it can be less than or equal to, it can be equal to, it can be not equal to. Okay? It can be any of those things. And there's some other things in Python that you can use, but we're not going to worry about that just yet. And if you have a variable that has a true or false value in it, as a Boolean, you can just type the Boolean variable. So, y, what does our y have in it right now? False, right. So if I say if y, we're going to use something called prints greetings. Okay, so was y true?
No.
No. So I said if y, print greetings. Y was false, so we did not print greetings. Now in programming, print usually does not mean printing like to a paper. It means outputting text or something to your console window or terminal. But if I say if x is greater than 30, because x is 340 now, it's not 5 anymore, right? We changed it. Then I say print greetings. It says greetings. Okay. So everybody see how that code works? I'm falling backwards.
So the first thing we need to do is ask the.
If you need to see it closer, just let me know.
So how do we just make work?
Because I realize the text is kind of small. Huh? We still don't have them yet. When we have them, then we can.
We have to build them first.
Yeah. There are other things that I'm not going to show you the code for it just yet because it's kind of complicated. Well, it's just a lot to take in. It's not really complicated. But have you guys that are in algebra or starting algebra, you know what functions are, right?
Yeah.
What you could do.
Like y equals something, or you say f of x, right? You have f, and then parentheses, x, close parentheses, right? And they have an equal sign. So in this case, x is what we call a parameter or an argument. Either way. And so if you say f of x equals 3x plus 2, you have defined a function called f of x, or f. The function name is f. And it takes one argument, and the argument's name is, any guesses? X. That's the name of your argument. Right? And so then, if you write f of 3, okay, you're going to get whatever that value is. I think I said 3x plus 2 or something, so that would be 11. A lot of programming comes from math, and so programming also has functions. And they're a little bit different than math, but what a function is you have a name for your function, you have arguments to your function, and then you write code that uses those arguments to do something, or calculate a value. And we'll go over that more later in the week, because that's just a lot of code to take in, and you guys have already kind of taken in a lot. So, real quick, if I have a variable that has the value 5 in it, what is the type of that variable? Any guesses? No? An integer. Yeah. What if I have 200.325? What type is that? We only covered this one really shortly, so it starts with an F. Any other ideas?
Remember FX22?
FX22? No. Okay. So if you have a decimal in your number, the data type is called float. Okay? What about true and false? Does anybody remember the name of that variable? Boolean. Good. Okay. Did everybody catch that? No. Can anybody tell me like what we called the most basic element of control flow? Is the most recent, or second most recent thing we went over.
It takes anything after that.
Was that?
So it's the same thing as doing it.
No, well, no, it's not reading. Who said that? Float is data type with decimals. Function? No. Although function is a type of control flow. Good thinking.
If else?
If else. Yeah. That's what our control flow is. So, once again, control flow just controls what your program will and will not do. So, remember how we're like, well, what's the square root of -1? And it's I, it's imaginary. You guys don't know how to actually find that, right? So if you have a program that finds the square root of a number, right? You don't want negative numbers. You can't get the square root of negative numbers. So you say, well, if the number the user has asked me to do is negative, screech at them. And then your program will screech instead of try to find the square root of negative numbers. Good? Screech? It's like yelling, except really high pitch.
So the computer does that?
No, you can also just make it print to the screen. Well, I think we may get to doing some audio this week, but I really want to cover some like just regular programming though. Okay. I'll tell you what, until Queso gets back here with the PyTalks, you guys can go ahead and get on the computers and play Armageddon, or if you have a Minecraft account, you can sign in with that. Rocket League, we'll have to wait until I get Steam keys, okay?
Yes.